So here's an interesting problem that I heard on Car Talk a number of years ago, Click and Clack to Tappet Brothers, and it involves a car that goes up a hill and then down that same hill. When it goes up the hill, it travels at a speed of 40 miles an hour. And when it goes down the hill, it travels at a faster speed of 60 miles an hour. It's a very simple question, and that is, what is the average speed of this car on that trip? Most people's inclination is to say 50 miles an hour, halfway between, average the two numbers. It turns out it's not 50 miles an hour. And the reason it's not 50 miles an hour is that you spend more time going up the hill at 40 miles an hour than you do going down the hill at 60 miles an hour. So how are we going to figure this out? We're going to figure this out by breaking this problem into two parts. So you have an up part and you have a down part. The definition of speed is simply distance divided by time. Now, that's true whether you're talking about the overall distance or whether you're talking about the distance for just part of the trip. So we're going to be talking about the average speed for the whole trip, the total. So that's going to involve the total distance divided by the total time. Total distance, well, we don't know how far it is up the hill, but we do know that it's the same distance up the hill as it is down the hill. So let's go ahead and call that distance 2d, because it's some distance d up the mountain and some distance d down the mountain. So the total distance is going to be 2d. But what about the total time? To figure out the total time, we're going to have to break this into two parts, up and down. Well, if speed is distance divided by time, it makes sense that time is going to be distance divided by speed. So if we want to know the time up, that's going to be the distance up the hill, or d, divided by the speed up the hill, which is going to be 40 miles per hour. Similarly, the speed down the hill, where it's 60, should be shorter. Well, that distance is also d, but the speed is now 60 miles an hour. And d divided by 60 is indeed smaller than d divided by 40. So if we want to get the total time, that total time is going to be equal to time 1, or time up, plus time 2, or time down. So that's going to be d over 40 miles an hour plus d over 60 miles an hour. But how do you add those? Well, let me take the units out of the way to make it just a math problem. You can get the common denominator, but a nice little math trick that I like to use is if you multiply diagonally, 60 times d gives you 60d, 40 times d gives you 40d. Now what you can do is across the top just add those. That's going to give you 100d. And the bottom you're going to multiply, 40 times 60. And that will always give you a denominator that's common to both of them. This trick only works if you have two fractions to add. If you have more than two, it doesn't work. And you're going to simplify that, see the zeros cancel out, and you're going to get that the total time is going to be d divided by 24 seconds. Then you're just going to plug that in, d over 24, and you can see the d is going to cancel out, so it really doesn't matter what you use for the distance. A lot of students, when they first approach these problems, they like to just make up a number, and that's fine. But whatever number you put in, it's going to cancel out. And in the end, when you divide 2 by 1 over 24, that's the same as multiplying by 24, that is going to give you a final speed of 48 miles an hour. And this is consistent with our thinking that you're going to be spending more time going the slower speed, 40, than you are going the faster speed, 60. So your average speed overall is going to be closer to the 40. Big picture here is whenever you have a mixed speed problem, what you're going to have to do is you're going to have to take the total distance divided by the total time. To get the time for the pieces, you're going to have to calculate that separately. In this case, up and down. By the way, about motion vocabulary, it's worth pointing out, what would the average velocity be here? Well, average velocity is very similar to speed, but it's now going to be displacement divided by time instead of distance. And if it goes up the hill, turns around, and goes right back to the same place it started, that would be a displacement of 0, which would give you a final average velocity of 0 meters per second as well. So that is how you approach a mixed speed problem.